For centuries, Viking longships were the absolute masters of the North Atlantic. They pulled off feats of open ocean navigation that, honestly, seem almost impossible even today. So today, we're going to crack the code on one of their most ingenious and legendary tools.
Right, let's just start with the central puzzle here. The magnetic compass? It didn't even show up in Europe until around the 13th century, way after the peak of Viking exploration. And yet, these sailors were confidently crossing a huge, featureless ocean. So, how on earth did they do it?
And look, we are not talking about short little trips along the coast. A standard journey, say from Norway to the southern tip of Greenland, was over 2,500 kilometers of seriously treacherous open water. This wasn't just luck or guesswork. This had to be a reliable system.
Okay, let's dive into this incredible navigational puzzle. First up, the impossible journey.
For about 300 years, these voyages weren't some rare, crazy exception. They were routine. The Vikings set up colonies in Iceland and Greenland, and they famously became the first Europeans to land in North America. All of it powered by wind, muscle, and some seriously clever navigation.
So, how did they even begin to figure this out? Well, they weren't completely without tools. They didn't have a magnetic compass, sure, but they had a really clever way to navigate by shadow. And archaeologists have actually found the first major clue. This right here is a reconstruction of something called a sun compass. It's based on a real piece of a wooden disc found in Greenland. And it's just a beautifully simple device. You've got this central pin called a gnomon that casts a shadow onto the dial.
On a clear day, using it was just brilliant. The navigator would turn the disc until the very tip of that shadow touched the right carved line for that time of day, and bam! They could instantly find the direction of true north and keep their ship on course.
But here is the massive, obvious problem. The North Atlantic is famous for its fog and overcast skies, right? And up in the high northern latitudes in the summer, the sun barely sets. You get these long periods of twilight where a shadow is pretty much useless. This is where the sun compass fails, and this is where legend takes over.
So, this brings us to the Icelandic sagas. These old epic poems mention this mysterious object called a Sólarsteinn, which literally means sunstone. For the longest time, everyone just thought it was pure myth. But what if it was real?
Now, this is really important to get straight because it clears up a huge point of confusion. When most of us hear sunstone, we think of some sparkly gem you'd see in jewelry. But the Sólarsteinn from the sagas, that was something completely different. Researchers are pretty sure it was a specific type of crystal with a very unique optical property, Iceland spar.
Iceland spar is this incredibly clear form of calcite, and it was pretty easy to find in Scandinavia. Its superpower is a property called birefringence, and what that means is, when a ray of regular, unpolarized light, like the light from the sky, hits the crystal, it splits that one ray into two.
And this bizarre light-splitting trick, that's the whole key. It's what lets a simple, natural crystal find the sun even when it's totally hidden from view. So let's see how this magic trick actually works.
So when you look at something through a piece of Iceland spar, you don't see one image, you see two. That's that birefringence effect I was talking about. But for a Viking navigator, the real magic happens when you're not looking at an object, but just at a patch of sky.
So here is the technique. A navigator holds the crystal up to a patch of sky, even a cloudy one. As they turn it, the two images of the sky they see through it start changing in brightness. The goal is to find that one perfect angle where both images are equally bright. At that exact point, the crystal itself is pointing directly toward the hidden sun. Incredible.
And just how well does this work? Well, modern experiments have shown that by finding this isotropy point, you can figure out the sun's direction with an accuracy of plus or minus 1 degree. That is astonishingly precise.
Okay, so the science totally works, and the sagas give us the legend. But a great theory needs physical proof, right? So where are all the Viking sunstones?
Well, the hunt has been incredibly tough. Remember, Iceland spar is calcite, which is a really soft and fragile mineral. It just doesn't survive well over hundreds of years. It can dissolve in the soil, and if it gets heated up, like in a Viking funeral pyre, it shatters into a million tiny, unrecognizable pieces. But then we got a breakthrough. In 2013, archaeologists were digging through a 16th century English warship that sank, and they found this, a cloudy, rhombus-shaped crystal. It was a big piece of Iceland spar, sitting right next to a pair of navigational dividers.
Now you might be thinking, wait, why would a 16th century ship need a sunstone if they had magnetic compasses? Well, this quote from the researchers gives us the perfect answer. The massive iron cannons on a warship could throw a magnetic compass off by as much as 90 degrees. An optical compass like the Sunstone would have been absolutely essential to get a true reading.
So where does all this leave us? Let's put all the pieces together and see if we can get a final verdict on this ancient GPS.
Okay, this is the crucial takeaway. The sun compass and the sunstone were probably not competing tools. They were a complementary system. The sun compass was your go-to on a clear day, and the sunstone was the amazing backup that let you find the sun through clouds, fog, or even in twilight.
And modern science just keeps backing this up. Experiments that recreate using a sunstone with a kind of sun compass show it works remarkably well. Look at this. Navigators could find true north with an error of only about plus or minus 4 degrees, even when the sun was 8 degrees below the horizon. That's just wild.
And that really brings us to our final thought. Look, have we found the smoking gun, a sunstone in a Viking ship burial? Not yet. But the evidence is so compelling. You've got the ancient sagas, the hard science of polarized light, modern experiments that prove it works, and these tantalizing archaeological finds. It all paints this powerful picture of an ingenious solution to what seemed like an impossible problem. It really suggests that a simple, clear stone might have been the secret that gave the Vikings the confidence to literally sail off the edge of the map and into history.